Hey, hey!
Don't clap too long, you're cutting into my time. I skipped Hebrew class to learn JavaScript, so that's how I ended up here and you ended up there. All right, so welcome to Esoteric JavaScript for Practical Performance. Woo! So what we're going to do here, we have a really cool pattern. Hi, I'm Nick. I work at Mobileye. We can go to the next slide. We have some really cool stuff. I can't show you our actual stuff for legal reasons, so we're going to have to imagine it. Everybody here at Super NES? Yes. So imagine we're playing Star Fox, and we're flying through space, and we have lots of 3D objects being rendered. So that's what we're trying to accomplish. We have a lot of data coming in. It's coming in for future frames. We have huge amounts of slices of data, and we're going to use a proxy to zip our data together just in time, and we're also going to see where we can build cool features like prefetching, caching, and it's going to be great. So what is a proxy? First off, not everybody uses proxies every day. They're super cool, they're super great, but this is a talk about esoteric JavaScript. So I have a couple slides here. We're going to cover what is a proxy. So basically, look at this object, really cool. We can think of it like we have a database. Here we have source key and val, really basic stuff, but this is a metaphor for we have databases. We could have anything backing our data. We have a consumer query here, so this is like our API call. And in between the two, we have brackets. Hooray. But that's basically where the proxy lives. That's when I imagine the code running in my head. That's where I imagine the proxy sitting in the middle, playing both sides, trying to win some kind of prize from playing both sides. So let's do a little play on words. OK, everybody with a keep is laughing. Great. OK, so we have a target object here, the world. How a proxy is built is we have traps. So get and set, these are the ones that should be pretty straightforward to understand what they do. When we try to read data out of an object or put data in, we're going to have our get or set trap called. Here we have the has trap. The has trap is what JavaScript goes to when you use the keyword in. We're asking if something's in something. Here, Enya ush ba'olam, for those of whom didn't get the play on words at first. And that consumer doesn't know the difference. That's the big key. That's like the big sale point. So I've got a little example here of something really common. So virtual scrolls, infinite scrolls, will often be a complicated library that we don't want to get into. Proxies, a huge use for us is we don't want to mess with the other code over there. We're the source side. We're not the consumer side. So we want to build our code on the side that normally we wouldn't be able to. We want to play the other side of the equation because that's the one we can. So here, it looks like this code isn't going to run. Our object doesn't have a .name. It doesn't have a .great. For anyone wondering, the shy what line does also evaluate to true. But, you know, I put that in for shy. So here, we can make a get trap. We're now going to return, instead of just the is great value, the true or false statement, we're going to return an object that has a name or a great. And in this example, I was imagining that the virtual list was doing a .key, an object.keys. However you want to implement it, the own keys trap is also very useful. Here, I'm using it to make sure that we have a deterministic alphabetization of the keys. So why do we use proxies in real life? What we use them for often is because we have multiple data sources. They're these massive typed arrays, and we don't want to use all of them at once. We don't want to loop over them all at once. We want to leave them where they are and just read out of them as an abstract backend. The example we just saw, the external lib, lazy loading is great. And I've seen some great examples with extending Pojo, where you're putting a side effect into a setter, and then you're using the proxy to do something in the backend instead of actually doing stuff. All right, so this is the example. This is the one where I want us to imagine we're playing Star Fox. There's a lot of 3D stuff loading, and we want to load it into the future and be able to see what's there. We're loading data from two different sources, for instance. There's position data for these things, and then we have some kind of rendering data of the triangles, of the graphics, of the shapes of these things. if you didn't play Star Fox, then you're just not going to get the reference. OK, so this is our example. We have 2 arrays coming in, and we want to merge them together into 1 array. So who wants to use .map? OK, obviously, you read the title of the talk. So if we use a .map, I did do this as an example. We're taking the positions. I don't know if you can see the mouse. We're taking the positions, the shapes, and the colors, and we're putting them together. We're using the indices to just put them together into the slices. We're taking slices and making them into frames. And we get this really slow animation. This is, I don't really know how to program Star Fox, even as much as I've played it. And I've got a little counter up in the top for the number of milliseconds we're using just to do the .map. So if you're trying to run at 60 frames per second, you only have 16 2/3 milliseconds, and we're using most of it just on a single .map. So there's good and not good, and that is not good. So what are we going to do? We're going to use a proxy. We're going to get in the middle, and we're going to play both sides. So we don't want to actually do the work until just at the last moment. We're going to zip everything together. And this is why I called it the zipper proxy, because that looks like a zipper. So our consumer code is really straightforward. We're going to use a, what do you call it, spread? I always call it schmear because I like bagels. So we're going to use a schmear operator, and that's the only thing we're going to use to read data out of our proxy. We're not using any of the normal traps. We're going to have to use a kind of special trap here, which it's the get trap, but we're just selecting for the key being symbol.iterator. And this is esoteric JavaScript, so we do get a generator. I was pretty happy how that worked out. This is our first step. So we're zipping everything together. And the second step we're going to do to get a real performance gain is we're going to program in between the if statement and the return statement, we're going to put a caching layer in. And that way, we save basically all the time. So this is all it is. This is this big, complicated proxy that nobody wants to do in their code reviews. But it's very simple in this instance. We're caching. We're computing all the positions for a given slice of data. And we're rolling our window over those slices of data to pick out 128 for the frame we currently want to render. I didn't really have time in this. In a 7-minute talk, I can't show you pre-fetching our data. But we can imagine this is approximately how it would look. Instead of caching data and doing our cache hits, we're going to pre-fetch our data once we get close to the end of the data we've already loaded. And it's all kept away from our consumers. It's all kept away out of React. I don't know if you learned anything in the first 2 talks. I learned that React is a place that bugs go to live and pay almost no rent. So when we cache everything, look at that. We're saving almost the entirety of our 15 milliseconds. And I actually have this running in my browser here, over here. This is the slow version. And I got to do a little live coding. So I'm going to get rid of that exclam. And now, bam. Bam, 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 that is fast. I also wanted to torture everybody with a little bit of light mode Emacs. So let's get back to the slideshow. Why do we want to use a proxy in real life? Often it's because we have 2 sides of our code. We have a library who's consuming our data, or we have a library that's giving us our data. We're on the other side, and we want to play the other side and use the proxy to sit in the middle to solve a problem that otherwise we wouldn't have been able to get into the middle. Like we saw here, prefetching, caching. A really cool way of doing caching is non-sequential indexing. So treating an array as like a looped linked list. You can do that with a proxy and not have to have a computer science degree. I'm a computer science dropout, represent. And basically the #1 thing in terms of performance gains for using proxies is actually not running our code, it's our dev efficiency. So because we don't have to go into the library and fix something and make a pull request, or interface with some other team, or go through a code review over there, we can code on either side that we want, and we can make the win where we want it, so we can get that dev performance. Why don't we want a proxy? Basically, our console.log is going to be harder to use. You can hide some really, really terrible bugs inside proxies. I can read the same thing out of the proxy, and because it's a function, I get different values every time. So stuff you thought was invariant is no longer invariant, and now you're confused. I put the this joke in there. There's part of the trap we actually have a third parameter that we didn't see in the slideshow that gives us information about what the this parameter for a given trap is going to be. And yeah, good luck getting your code reviewed if it's a proxy within a proxy within a proxy. So there's my cat tax. Any questions?